All right, everybody, welcome back. We are looking at the notes we took in the book on pages 81 to 85. I believe the section was called Atoms, Ions, and Isotopes. We're going to first look at regular neutral atoms versus ions. And I've been saying to you all along, when we use the word atom, it refers to a neutral atom, so that we're going to have an equal number of positives and negatives. So the number of protons is going to be equal to the number of negative electrons. When the number of electrons does not equal the number of protons, instead of using the word atom, we use the word ion. We don't call them atoms, we call them ions. The term ion, I'm noticing a typing error, is used when an atom has an unequal number of protons and electrons. The number of protons, the protons for each element is constant. And that means that if I have a fluorine atom, it's going to have 9 protons and 9 electrons. If I have a fluorine ion, it will have 9 protons, but maybe 10 electrons. All right, so the protons stay the same. The electrons are what is different. So this is a fluorine atom, and this one is a fluorine ion. There's two kinds of ions. You can have an ion where you have too many negative charges, so it's called a positive ion. I'm sorry, I messed that up. We can have a cation or a positive ion where you have a higher number of positive charges than negative charges. It's written with the symbol and a small little number to the top with a plus or a minus usually. And sometimes this is potassium, and it might just be written potassium plus, and that signals +1. So potassium usually kicks out its outer electron when it's hanging out and combining with other atoms. And so what happens is then it ends up with 19 protons and 18 electrons. So overall the net charge is a +1. And that's why we call it a +1 charge. Anions are negative ions. This is like fluorine. Fluorine has atomic number 9 and has 9 protons. Fluorine is really kind of a bully element in terms that fluorine will very easily and readily take electrons from anybody else. Fluorine's a pretty strong atom. So fluorine will have 10 electrons and 9 protons, giving it a -1 charge overall. And likewise, you might see it written as F with a minus sign. And that means the same thing. And that means that fluorine gained electrons. So it has more electrons than positive, which is why it's negative. And cations, which are positive ions, they lose electrons. They've given away their electron. So now here comes the really bad joke. Two sodium atoms are walking down the street. One says to the other, "I lost an electron." "Are you sure?" "Yeah, I'm positive." So if you've groaned at that, you kind of get the idea. All right, and then Monday in class, we talked about what valence electrons are. And valence electrons are the most important electrons when we're talking about inorganic chemistry and we're talking about chemical reactions. The valence electrons are the ones that are furthest away from the nucleus. There's anywhere from 1 to 8. And these are the electrons that are lost or gained when atoms are combining and making compounds or molecules. So I am fond of saying that atoms are a particle of matter where it has an equal number of positive and negative charges. And let me get rid of my battery signal here. And an ion is an atom that has a charge because it has a different number of electrons than normal. So ions are like atoms, except their number of electrons are messed up. And the biggie to remember is electron. The electrons are the ones that alter, not the protons. So here we did an example of magnesium. It's atomic number 12, mass number 24. If magnesium is a +2 ion, it means it gave up 2 electrons and now has only 10. You won't have to do the math necessarily for the test, but you do need to be able to look at a Bohr model of a magnesium and be able to identify if it's an ion or not. And the way to do that is quite simply, I'll draw our Bohr model for magnesium here. We have 12 protons, 12 neutrons. Magnesium is, I believe, in the third row of the periodic table. So it's going to have 3 shells or orbitals. And I forget how to change my color. So I'm going to put in its normal 12 electrons. 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12. Well, if magnesium is an ion, what will happen is that this electron and this electron will be handed over to somebody else. And yes, I'm at school. And now the outer shell, the orbitals or the shells don't exist. They're just paths in which the electrons travel. So if there are no electrons in that outer path, the next outer path is the second shell right here. And that now becomes the valence shell. And this magnesium is happy because its second shell, its valence shell now, has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So we'll talk more about that when we get into chemistry. But that is the lowdown on ions. Now, ions are atoms that have goofy numbers of electrons. Isotopes are atoms that have goofy numbers of neutrons. We've talked a little bit about this in class, but basically it's an atom that has a different number of neutrons than normal, and so it has a different mass number. So when you see a normal atom, and I always say not, especially the bigger atoms, the number of neutrons is greater than the number of protons because the neutrons space out the protons. So it's not unusual to have, 19 protons and 22 neutrons. It's a pretty ideal state. So if your number of neutrons is slightly off from your number of protons, it's fine. Even if it's off by, 10 or 15, it's fine. For an isotope, for an atom to be called an isotope, it has a different number of neutrons than it normally does. So here, regular atom carbon-6, it has 6 protons, 6 electrons, and 6 neutrons. This is carbon. Normally, it's an atom. The positives and the negatives are equal. If it is an isotope, we wouldn't even call it carbon anymore. We'd call it carbon-14. And this 14 is the new mass number. So this carbon has a mass number of 14 instead of 12. So we still have 6 protons, 6 electrons, but now we have 8 neutrons. The neutrons don't affect the charges, it just affects the mass. So this is a heavy carbon atom. This is a carbon atom carrying around a little bit more mass than normal or ideal carbon atoms. That is the lowdown on isotopes. And again, we would, if we were going to draw a Bohr model for this, it would look something like this. 6 protons, but now 8 neutrons. It's in the second shell, so it's going to have 2 rings for electrons, and here are the 6 electrons. So on the test we will have, I can't remember if we show isotopes with Bohr models or not. I don't think so. But again, when your neutrons are messed up, it's an isotope. If your electrons are messed up, it's an ion. And if everything's normal, how it normally is on the periodic table, then we call it an atom. Alrighty, I think we have a worksheet coming up that we'll do in class. So that's where we are left off with. Please add any missing detail to your note. Rewind, go back, do what you have to do, and be ready for Tuesday to talk about ions and isotopes. Alrighty, have a good night, guys. Bye.